Jo, dann herzlich willkommen hier im ersten Meetup dieses Jahr bei uns in Coavia. Ja, einige kennen die neuen Räume ja schon, andere sind zum ersten Mal hier, glaube ich. Ich freue mich, dass es jetzt auch wieder klappt. Und dass wir den Alex haben, der uns was über Rook erzählen wird. Ganz kurz noch, wie gesagt, Getränke sind da. Essen habt ihr wahrscheinlich auch schon gesehen. Könnt ihr euch nachher auch einfach bedienen, wenn Alex durch ist und die Fragen angeklärt sind. Hier auf dem Tisch liegt noch Zeugs, was ihr euch auch gerne anschauen und mitnehmen könnt. Ja. Ansonsten, danke, dass du kommst, dass du uns was erzählst. Viel Spaß.
Ja, danke. Ja, ich bin Alexander Trost. Ich bin so nebenbei ein bisschen am Rook am Arbeiten. Erstmal, passt Deutsch oder ist irgendjemand?
Mein indischer Kollege kommt gleich noch, dann auf Englisch.
Ja, aber ich habe gerade die Introduction auf Deutsch noch und dann können wir gerade auf Englisch switchen. Also rein an sich, ich bin Rook Maintainer, ich arbeite bei der Flexibility als DevOps-Ingenieur, habe da auch Anmerkungen, habe da auch meine Zeit an Rook verwenden darf, weil entsprechend von der Firma das Potenzial gesehen wird, also auch schon bei Kunden eingesetzt wird und es tut. Was das angeht, aber das mal wieder später was. Ja, rein von der Agenda, mal gerade erstmal so ein bisschen, ja, was ist denn überhaupt Rook, so ein paar Eckdaten oder Eckpunkte, so die Architektur, mal drauf eingegangen, wie ist das so auch irgendwo in Kubernetes mit eingeflochten am Ende dann, da genau dann auch im zweiten Punkt genau dann tiefer drauf eingehend, dabei dann die speziellen, sag ich mal, Objekte in Kubernetes, die sich ja grundlegend schon mit dem Thema Storage beschäftigen, Storage Class, Persistent Volume Claim, darunter auch schon mal vorweg hängt natürlich noch Persistent Volume, wem das schon was sagt, und sozusagen als Abschluss dann der Kubernetes-Integration dabei nicht die Custom Resource Definitions. Auch vielleicht hast du mal die eher unter der Kurzform mal gehört, die CRDs. Will ich mal gerade darauf eingehen, was sie halt anbieten und warum sie auch so cool sind in Kubernetes und an sich genau für Projekte wie Rook. Dann mal auf den Punkt zu wissen, da überhaupt mal, warum sollte ich überhaupt Rook laufen lassen? Also mal speziell eher die Frage, warum sollte ich in einer Cloud wie AWS, in der ich ja meine EBS, gibt es auch ein Filesystem? Warum sollte ich da dann sowas wie Ceph laufen lassen, wo ich doch eigentlich alles von der Cloud habe? Dann auf den Punkt, da die meisten eigentlich, die von Rook hören, sich glaube eher so, ach ja, das ist Ceph irgendwo, mal so ein bisschen Klarheit schaffen, auch überhaupt nochmal so, nein, also ja, es ist Ceph, aber noch viel mehr eigentlich, oder bei jedem Release kommt immer mehr dazu. Ja, und einfach so ein bisschen hier dieses, ne, wie, wenn man Interesse hat, irgendwie sich mal noch anzugucken oder auch mal Hilfe dann bei was braucht, wie man da auch sich Hilfe besorgen kann und wie man einfach auch mit involviert werden kann in Projekte. Kann mit Spaß sein, oder in der Community auch halten. Ja. Dann einen unbekannten Punkt, mal so ausgedrückt. Da total spannender Punkt. Und nach dem spannenden Punkt kommt dann einfach nochmal so, sagen wir mal, Demo. Also ich habe jetzt gerade nochmal schnell mir kurz ein Newscluster hochgezogen, mal jetzt noch mit Hessacube, falls das jemand von euch was sagt. Hier, der nette Herr Xetis, wie er heißt, hat das Tool geschrieben, mal gerade so ein bisschen, weil das Tool ist einfach gut. Wie heißt es? Hessner-Cube. Das sagen wir mal, ist mein Go-To-Tool, wenn ich zum Beispiel Kubernetes das brauche. Man kann als so ein bisschen als Geheimtipp, wenn ihr was braucht, ich brauche klein Kubernetes, auch mit mehr Nodes natürlich, aber jetzt schnell Kubernetes und nicht über, wo man auch volle Admin-Rechte hat und nicht irgendwie umgeklappt oder so. Ja, das nochmal am Rande. Genau, was ist Rook? Rook ist, machen wir mal das Cloud Native mal kurz zur Seite, ein Storage Orchestrator. Grundlegend macht Rook nichts anderes als ein Storage für dich orchestrieren, also dich als Admin, Operator, entsprechend der Name eigentlich auch Rook Operator sozusagen, also operiert, orchestriert für dich das Storage Backend, Storage Software, wie man es nennen möchte, entsprechend im Hintergrund. Das heißt, wenn ich jetzt natürlich entsprechend sowas wie Ceph laufen habe, würde das bedeuten, dass es sich entsprechend jede Komponente, die nötig für den Betrieb des Clusters ist, aber zum Beispiel natürlich auch dafür zuständig ist, wo die Daten gespeichert werden, dass die entsprechend orchestriert, gemanagt laufen. Also ein normales Beispiel mit Kubernetes, Pod auf Node A fällt weg. Was passiert? Pod A, oder das ist dann ja, wird ja deleted, also wird ja entsprechend erwichtet von dieser Node, wird dann entsprechend auf eine andere Node übertragen, also normalen Pod reschedule. Da kümmert sich natürlich aber auch entsprechend der Operator drum und schaut, dass wenn dann nach x Zeit eigentlich nichts ist, so, oh, wir müssen mal eingreifen und ein bisschen hinterher treten, das was passiert. Das Extenden von Kubernetes passiert mit den CRDs, wie so ein bisschen bei der Agenda schon erwähnt. Rein an sich, Rook bringt halt seine eigenen Objekte mit, also wer Pod, Service, Deployment in Kubernetes schon kennt, der wird es wahrscheinlich erstmal sagen, das ist aber auch nicht in Kubernetes verfügbar. Das kannst du schon machen. Das kannst du schon machen, dass die verfügbar sind. Da brauchst du nur entsprechend eine Definition schreiben, wo effektiv drinsteht, dass meine Objekte, die da so sind, so und so heißen sollen und so. Aber natürlich macht es keinen Sinn, diese Objekte einfach zu erstellen, wenn man auch wieder was möchte, was entsprechend hinten dran irgendwo reagiert. Und da auch schon mal direkt so ein bisschen dieses Operator-Pattern in Kubernetes mit diesen Custom-Types. Ich erstelle meinen Custom-Type und bekomme effektiv dann mit einem Controller, Schnittstelle Operator hin, dass der darauf reagiert, dass zum Beispiel einer erstellt wurde. Ja. Rook schaut genau mit dem Punkt Storage Orchestration dafür, dass es zum Großteil das Deployment, Bootstrapping, Configuration, Provisioning, Scaling, Upgrading, Migration, Disaster Recovery, Monitoring und Ressourcenmanagement so gut wie es geht versucht abzukapseln, dass der User also Standard-Prometheus zum Beispiel, der ja für Monitoring dabei ist, über die Standardannotation halt entsprechend direkt die Services einfach mitnimmt für bei Ceph zum Beispiel den sogenannten Manager. Momentan ist momentan noch speziell dieser Deployment-Punkt eigentlich das Größere bei Rook, so dieses Update ist auch so langsam immer mehr gekommen, aber noch mehr in dem limitierteren Fokus momentan, dass wenn ihr bestimmte Komponenten habt, dann werden die geupdatet, aber wenn ich jetzt zum Beispiel die Konfiguration, wie eine Platte gerade aussehen soll, sowas ist momentan halt noch nicht gehandelt. Man will halt einfach nur dieser Daemon, der da in einem Pod laufen würde, halt entsprechend mit der neuesten Version ausgestattet, aber halt noch nicht entsprechend mit neuem Display oder ähnlichem versehen werden. Das sind alles entsprechende Punkte, an die wir arbeiten. Das ist auch am Ende des Ziels, dass man entsprechend in einer schönen Definition, wo eher Richtung auch mal Ceph gesagt, da gibt es das sogenannte Dashboard. Ja, dann switchen wir gleich. Und im Dashboard zum Beispiel, dass man da auch eigentlich sich so ein bisschen Drag-and-Drop-mäßig sein Zeug zusammenschieben kann, wie man es halt entsprechend haben möchte. So, we're going to switch to English now.
Thank you.
No problem. Yeah, exactly the point here with updating and, well, the automatic updating and migration stuff is here. For example, if you upgrade a root cluster from the last oldest version to the current latest version, it will automatically see which Ceph version you wanted to. You had running basically, and then see, depending on the version you have running, and especially for upcoming releases, depending on that, make decisions if it should run a certain command or something to do certain upgrades, path settings, set them, for example, or migrations for set. Rook is a framework for, well, as I already kind of teased with one of the points in the agenda, or let's very quickly, the agenda, so just a bit of what Rook is, the architecture, how the integration is, the storage class, persistent volume claim, and custom resistive conditions, why Rook in a model itself, how to get involved, and a sneak peek point, something like unknown, and then a small demo. So, as we have with the more than Ceph point on the agenda, Rook is not only running Ceph for you in the end. It is in the end, depending on how you see it, there's an actual just Rook Ceph operator. But there's also a Rook min-IO operator, a Rook aims bucket name storage here, and add minus operator behind it, and you have Yeah, it's just not one thing. It's more than one software there. Well, kind of obvious, I hope. It's open source, the Apache 2.0 license. It's hosted by the Cloud Native Computing Foundation. Yeah, so if you should be at KubeCon or something like that, there's a pretty high chance you will see either me or one of the other team members. Yeah, they will also. Yeah, they are also coming to Europe in the last year, so this year probably there. So, as we kind of established with the point that Ceph is not the only software storage backend Rook can run, it's more or less, yeah, as it says, a collection of operators for, as already said, like the Ceph operator, the Minai operator, the CockroachDB operator, and so on, basically. But we're trying to go to a way where we're more or less like a framework, where it's easy for you to say, hey, I have my IBM or something who comes and, hey, we have a storage software and we want to run it in Kubernetes, kind of. And you are like, yeah, here, Rook framework, it's pretty simple to integrate with you. It's not perfect. We're working on it, but at least for us, a pretty solid sign that we're going the right direction. Maybe what are they called? Nexenta says something to one of you. They have basically like their own storage software called EdgeFS, and they went ahead. We're like, hey, we want to integrate with Rook, and now they have, well, thanks to part of the framework here, created their own EdgeFS operator within the Rook project there, which can, well, run EdgeFS in your Kubernetes for you. And that's the cool part. In general, though, again with the framework part, in the end, we all end up at the point of Kubernetes with the so-called operator pattern. With the custom resource definitions and the framework that Rook tries to offer to the projects there, want to integrate, they get like storage resource normalization, like for example, Rook has like a plugin for a mechanism in Kubernetes to mount and unmount volumes on servers. And otherwise, well, the project would need to code that themselves, and it's I'm pretty sure some stuff in there is auto-generated, but it's always a bit spooky looking at that code. So, just getting some general specs there. Also, we have a common Rook types Go file, which simply contains like storage selection. The name of nodes and device selection, stuff like that, is on one common ground that when at one time CephFS and EdgeFS are not the only big ass storage packets which really use, for example, disk or something, that it's easy for the others to have it on the same level there, and to build like that, to just copy and paste the device definitions from A to B, potentially. Now to the architecture. Those are the CRDs I'm talking about for Rook. For example, we have the Ceph cluster object, and then in Kubernetes, thanks to the operator and the custom resource definitions, with, for example, Ceph block pools, object search, Minai object search, EdgeFS, and so on. All basically thanks to the Kubernetes API that allows us to extend it that easily, because in the end, it's one of the operators just another pod that is running in your Kubernetes cluster. So you have your Rook operator, or even multiple. Let's say we go for that one with Ceph. There's you have on the nodes the daemons, the actual Ceph daemons. So for example, the OSD, which stores the data, the monitor, which kind of to keep it simple, monitors the other components of Ceph to ensure that everything is healthy. or react in certain ways when something is not unhealthy. And again, the Rook operator just normally uses all other Kubernetes objects, like you have cluster rule, or well, the better example would be config maps and secrets to, for example, generate a config for the Ceph component, or a secret for the Ceph component, create deployments, daemon sets to run the components in the cluster, and well, all that through the Kubernetes API. And as you can see here, here's a special part. This is basically a node. This is the Rook flex volume and or /CSI. To go a bit into that, flex volume is kind of like, the Kubernetes approach, where they were like, hey, we need some mechanism to allow other plugins to simply hook into Kubernetes in some way, to give it back here, to then, for example, in this case, be on the node, volume X should be mounted on this node, and then this plugin is called, and can then, for example, do Ceph commands to mount the volume on this node. And when it should be unmounted, the same the other way, basically. CSI is, depending on how you see it, kind of the better approach here, because flex volume is more or less just for like, we need something in Kubernetes now, and CSI is basically, well, it should work with every container thing. So you have CSI in the ending as implemented in, for example, Mesos, well, obviously Kubernetes too. Docker can speak it too, yeah. And just those platforms. So we kind of with maybe CNI says something to it. CNI? CSI is standing for Container Storage Interface, and CNI is basically the same for network. It's Container Network Interface. For both of these, the point of the creation of those is simply to have one common interface. Depending on how I see it, strike out the container, put common there, common network or common storage interface, which every platform can use to, for example, for network can get, I need an IP. I tell that to my CNI, and what do I get? I get an IP in return, which I can use and then, well, do my stuff with, basically. Same for storage. I go and say, hey, please, I need 20 gigabytes, and I get 20 gigabytes of storage again. So, yeah, simply to have a common ground. Flex volume, as I said, is we're hoping to, well, soon be able to migrate to CSI, as it's kind of just the way to do it. Yeah. Any questions if you see that picture right now still? Just making sure, because it's kind of a build-up from here. So, to just quickly summarize it one more time, we have the operator. You create one of those cool new Rook something, self-cluster or whatever objects. Rook operator sees. Rook operator creates the object it needs to fulfill this. For example, the Ceph cluster would then create all the deployments, configs, and so on that are needed for the Ceph cluster. And in return also the daemons and the Rook agent, which, for example, do the mounting, and well, the daemons are the actual components which are running. And the agent is, for example, then doing the mounting for this newly created Ceph cluster object that we just created. Yeah. In Kubernetes, there's already a storage solution, or well, not a storage solution, but just already management capabilities for it. We have, which we will soon come to in Kubernetes, for example, persistent volume claim, and storage claims, which are kind of the most common objects in that way, which allows us, especially as the admin, I run my command and then I get a list of all the volumes that are currently created basically in my cluster, and with that integration of Rook, there again, you have the same output. There's basically no workflow in the end changing. And another point which, depending on depending on how I see it, you with that, especially more or less going into the direction like with WinIO, which provides you with S3 storage, for example. If you move between clouds often, or, well, I don't know, just for fun or something, having one common object, the WinIO object storage object which you just create, and then have object storage which you can use, is probably simpler than always, oh, I need to know if my cloud provider has a different authentication than like with AWS or, you know, like, it's potentially a more portable way for you to have the storage. And in the end, to do one more back here again, with those objects, I need WinIO object storage with 3 instances in the background there. You just create one object and you don't need to manage anything else there. So that's more or less also the point where if you need it, it's pretty good, pretty simple to basically create and remove again. Because if you, for example, delete that, the operator will take care of to remove everything that was created by it. So yeah. It's also possible to have a dedicated Kubernetes cluster which is only running the storage backend, for example, Ceph in it. But it is more or less not too common approach right now because Rook currently has a bit of lag in feature to be correctly able to use storage from another cluster. So you would need to kind of return to the in-tree, the in Kubernetes existing volume providers. Like the Kubernetes itself has also ways to mount the volumes from Ceph, for example. But it's well, a bit less convenient. I think we had a slight improvement in comparison to the inbuilt volume provider and or the volume mounting system there of, for example, Ceph there. Going a bit further up here, we have in the end, you have simply your application that is running and it has a volume claim. It simply says, hey, I need 50 gigs of storage. So what do you expect? That your application is getting 50 gigs of storage. Or in Kubernetes terms, to put it like that, or possibly even more. If you, for example, create persistent volume claims or well, persistent volumes behind a claim by hand, and don't really specify any more parameters here in the volume claim, it will just go and see what will fit at least those parameters that are given by the persistent volume claim. Going down here, basically into the Rook namespaces, we have the agent which is installing and running the Flex volume plugin right now, which, as earlier said, does the mounting if requested by the node. We have here the operator. One component which isn't in the picture yet is the discover daemon. It's not, it's kind of in the name what it does. It's on the nodes discovering the storage devices you have. So basically meaning if you want a node with, let's say, 10 disks to use the storage, you must ensure that this discover daemon is running on it, because the discover daemon will run a few commands and write it as a JSON file in a config map then of what devices are in this machine, so that the operator can then make the correct decision of with the configuration you give in the cluster of the cluster object of how to configure the disk event there. From here on is basically the Ceph layer. You have the components of Ceph like monitor, manager, MDS, RGB, and OSDs. Monitors, as already said, are kind of like monitoring all those components here to make sure they're healthy and react to certain things to keep the cluster in health. We have the manager, which is for example, providing metrics, or for example, also the dashboard of Ceph. The Ceph dashboard is getting, for each update of Ceph right now, it's getting, it's looking better and better. We have the RGW beams, which are the radar's gateway. In the end, in Ceph, it's radars, which is taking care of storing the data you put into it and saving it in small chunks, small blobs. And radar's gateway is kind of like a way to expose that directly, for example, through an S3 API or Swift, or I think you can even run NFS style. I'm not sure if you need to run the RGB right now, but you can also have NFS, for example, to be run on Ceph if you have, let's say, older clients or non-Linux clients, which need to, for example, mount file system or share data together in a read-write many order, read-write many mode. The OSDs are kind of the backbone for the data. They're, well, saving the data. So normally this would be one disk, this would be one disk, and so on. You can also have directories for the OSDs. It's not recommended. It's more or less just a, hey, I want to play around with it, see how it goes, and then when you're like, yeah, let's push it to production, we would, well, use actual disk because going a bit into Linux there, if you have OSDs on directories, for every action basically you have to go through the whole POSIX layer and do like that. And if you use disks directly, you just need to talk to a disk and worry about that, and it's faster. Here we have one of those cool objects. This is still one of the older ones. This is, for example, we also have kind of a versioning going on that when we change things, it is not completely breaking. For example, in Kubernetes, like with version, there was deployment. It was, if I remember correctly, also at one point version 1 alpha, and then it was at one point version 1 beta 1, which did some changes to default behavior and parameters in the structure of the object. And then I think now that it's apps version 1, it's kind of the same. There has been smaller or bigger changes there from behavior or something, and this version is simply there to allow the user to then migrate in time, or not have to migrate everything before the update or something. So looking at here, we have the kind. This is a cluster object in this case. We are renamed as this is a Ceph cluster normally. Those were renamed for more convenience and better naming there to Ceph cluster now in the latest version. We give the whole thing a name, and in this case you have to name it the same as the namespace you're in. So if you put in a namespace example1, the name must also be example1, and namespace, as we said, must be the same there. The data the host path, to go into that a bit, if you want to try it out, Rook in the end is not, as it kind of says, data there, where actual data is saved. It's normally, if you don't specify any disk or something right now, the behavior is to use this path to create an OSD where then actual data is saved. But normally, if you use disks, for example, if you set this option to use all devices to true, it would use every empty device. So it must be actually empty, no partition, nothing on it. And it wouldn't detect any disk. It would then create a normal file, directory-based OSD on a disk, which is not optimal. And we're currently also looking into changing that default behavior. We have just like network options here, like a host network. In some case, in most cases, it's faster to use the host network stack instead of going through like the VXLAN with Flannel, Calico, or Weave network you have running there, but you don't just directly go to the nodes through the network stack. The storage part here is exactly like these use all nodes, use all devices, kind of like selecting of what you want. Like with all use all nodes, you would use all nodes with without taints on them, or anything that would prevent a normal pod from running there. You have also the option to specify exactly like tolerations and label selector and stuff like that for the certain components in the Ceph case there. And as kind of already said, with the use all devices, if you set it to true, Rook will check on are there empty devices, and if so, it will use them directly and do its thing. You can also again filter it. You can like say what is called like the small roof thingy there. And then SD, and then dot, and that would basically pick up any like SDA, SDB, SDC, and so on. Yeah, to know though, currently partitions are no-no. Currently, for 1.0, it will finally change when we are able to utilize LVM devices in their full extent. That for partitions, I think at least you may need to create them yourself, but that's worse than creating LVM for yourself in your deployment or something. Yeah, so, yeah, locations would be like, for example, setting for each component where it is. For example, data center is Frankfurt, and then you have in the end the so-called crush node, which is, well, I'm not going into deep into that specific where it's kind of like calculating where it would put data. So, and with such factors like location set, you can have it make decisions smarter in the end, if you then also go into the crush node and change it up a bit to your needs. Yeah. For the config here, this is also again like more or less a Ceph-specific thing. It's like which store type to use. Ceph has two store types right now. There again, kind of with the disk, using disk instead of like directories. Bluestar is more or less made for directories, and there's the other one is FileStore, which I think the name maybe implies it a bit. FileStore is more or less for like on-file system use, and Bluestar is, well, under the ocean blue maybe, yeah. Which is more for devices. Yeah. But in the end, if you create this, you will get a cluster, your Kubernetes cluster. You have your Rook operator already running. You create it, get your monitors that you need for for running stuff. You have your manager component, the OSDs on each node, even if you have multiple disks, they're each for each disk their own OSD. And yeah, Rook will take care of creating those resources for you.
Excuse me, and can you go back one slide, please? And this use all node means every node in the Kubernetes cluster is searched, and if there are unused devices, empty devices, then these devices are collected into a Ceph cluster. Is this right?
No, only if you have also use all devices set. If you have both of them true, so, well, use all nodes is in that regard on all nodes that it can normally schedule a node. Rook will not go there and be like, the node has attained, let me add the matching toleration for it. Rook will like, well, create on each node that it is able to create them, which is valid to put it like that, which is for example not ready, or like scheduling table, for example, also not. Yeah, and for you, if you have both of those true, all nodes that were able to run this discover daemon will, if they have empty devices, get them used for this cluster. Yeah.
And if a node dies, then your devices are gone too, so you have to be aware of that.
Yeah, but that's the part where Ceph is basically taking over, because Ceph takes care of the data replication there. So the only thing you have to worry about there with the data is that you have a big enough size of data replication, for example, like data replication of like 2 at least, for example, so that you have, if one node goes down, that you have at least one more copy of the data. And for even production cases, it's recommended to have at least 3 as a size of data replication, so that you have normally 3 copies, and if one goes down, you still have 2, and if the other goes down, you have, well, 1 more left. So, yeah, that's where Ceph is basically taking over. Yeah. this native integration. For Kubernetes, as said in the beginning, we have those already in Kubernetes existing objects which are there to manage storage for you, like for example the storage class. And if you kind of take a quick look over now here, this section 2 below, it's simply, we have a few parameters. We say who basically takes care of this, and yeah, in this case, which pool to use, which is important. You can just save data, but where in which pool, kind of like, and the cluster name in which cluster it should be saved, or well, should be selected to then see in the pool if it's there. It's, as for example, I think what could be another good example, like with NFS provision or something like that, you would also have here the parameters like username and password for the NFS server, or like the address and the amount option or something special that you want to give the provisioner, which then provisions the persistent volumes for you. But just quick point here, you can have the name as whatever you want. You can name it like micro storage class or something, and as long as Kubernetes would, well, create it in the API store, then Rook wouldn't care. Persistent volume claim, we had the storage class name, remember that? We have, it's again, normal Kubernetes object, we have like the name, a few labels here, a storage class, and that is the pointer of the storage class name. If we specify it here, this one will be used. If you didn't specify that, we would need to set one of the storage classes we have in the cluster as the default. If you have only one, Kubernetes will not be like, yeah, this is the default. You have to set it as the default. So as I said, if you don't set it and have root minus block set as the default in the cluster, it will take the root minus block in this case automatically because it's the default set in the Kubernetes cluster. Then we specify the access modes which are well, kind of like okay for this persistent volume claim. As said earlier, if you have persistent volumes created manually and not, for example, automatically provisioned for you, then if there would be another persistent volume available in the cluster with, let's say here would be read write many 2, and the other volume that only exists there is with read write many 2. Then the other persistent volume, for example, would also get hashed for this persistent volume claim. But if you specify a storage class name, Kubernetes will be like, hey, storage class, do something, and normally not take persistent volumes. This is kind of the simple part here. We have the, we say simple as normal in Kubernetes, like with resources memory or CPU, we say, hey, in this case, a request for storage is always in claims a request for storage. For application, it's normally like, it's request CPU, like, 1 and limit is 2 CPUs or something like that. And for SO storage is kind of the same way here with storage 20 gigabytes, so it will in the end up with at least the volume with 20 gigabytes. If we take the storage class, the persistent volume claim, we will install the Rook Ceph cluster on the Kubernetes. We will end up with a persistent volume of 20 gigabytes. And the application, if you create a persistent volume claim and directly an application which will consume it, it's, would get this persistent volume, which has been as an object there, created in Kubernetes, that you as an administrator of the cluster see it, that you see, oh, with this storage class and so on, there has been a persistent volume created, and in the end for the application, it's, the application gets it when it will then start up and have in their volumes like, persistent volume claim, use this and this from me. Now we're coming to the cool Kubernetes extension part there with custom resource definitions, or CRDs also called. It's simply extending. We can create objects, new objects, our own custom objects, by simply creating a custom resource definition in Kubernetes. we can define how they look like as long as it's valid for what was it called? For not Kubernetes, for the API mechanism in Kubernetes, so not like integer 128 bits. Kubernetes is able to handle it now. Because Kubernetes in that part is taking care for you to store those objects in the SD, in the data store of Kubernetes. So it simply gives us the possibility to give you basically an image, a YAML which has those custom resource definitions, so that you have simple extension with Rook in this case, with simplicity. There are other ways to extend the API server, like to name one, I think it was aggregated API server. This one is a bit more complicated, still doable, but well, simply a bit more complicated. Then there is, if you have a whole another API server or something like that, don't quote me on that, but which, well, it's more to do than just create something which listens on the Kubernetes API for their own objects. So, but those other extension cases also have their place in Kubernetes. But for Rook at least, or some, well, most use cases like user creates my custom object, I want to react to it, create some other stuff, and done basically. So, yeah. As it's with Kubernetes, though, to go on to this last point here on the slide, if you create a pod, it will look exactly like you specified, or well, described in this pod object / manifest. So the same basically applies for custom resource definitions. The user creates it, and it's looking exactly, it's describing, defining the custom state the user wants it. In this case, then the operator takes this custom state and does its magic with it. Here we have another example of just a bigger look at the Ceph clusters here. Just again, we have our kind or custom type kind. We have our custom API version here specified. And just you know, like as already said, those are our definitions. We have a Go file with some mechanism behind which is automatically generated to end up with something like this. Now we're coming to the question by Rook. I think I wanted to add something there on my not flat here, on my train right here. Yeah. Rook tries its best to simplify, for example, running Ceph in Kubernetes for you, already beginning with something like MinIO or CockroachDB, for example. You create one object, or especially saying it more or less like that. The developer creates one object. What do they get? A fully working CockroachDB or MinIO instance that they need. For example, especially with MinIO as an example, as I heard from one or two people doing it like that, they use, for example, the Rook MinIO operator in their development because they don't want to run a full-blown, they don't want to pay AWS for their testing stuff and so on, you know, or run a full-blown Ceph object storage, and they simply create those, well, small MinIO instances in the in our development environment, and test with that for the applications. Rook tries its best to self-manage, keep everything in health as good as it can. There kind of applies like with most Kubernetes parts with the failover, if a node fails, as long as you have enough nodes, and with that basically space, not in point of like actual storage space, but in simple space, that you have enough nodes, for example, where a stateless, in big quotes, component, like the monitor or manager or MDS of Ceph, for example, can be failed over to. Same applies for MinIO and so on, which if you don't have space for another pod on another machine, or even just from the resource side, well, it will break at one point definitely. But as I said, that's about normally with Kubernetes. If you don't have enough resources, in some way it will probably break at some point. Yeah. There also with the custom volume claims and storage class, dynamic provisioning, ID storage now, few seconds later, volume created, and the application can use it. And there's kind of already come up with exactly the point with, for example, running instead of AWS S3 or a big Ceph object storage in development, like a small mini-IO you create it and it's taking care, Rook is taking care that it's creating everything that is needed for this instance to be used. And yeah, we're trying to push more and more, especially with the cross-play guys. They're especially pushing towards also multi-cloud part, but also just in general approach to have, for example, object store, bucket provisioning, like objects or just automatically, like through a service, not service, what was it? Like a broker, I think it was named, service broker. Same for databases, you have CockroachDB running using the Rook also. Our goal is there to have, at least for CockroachDB, like a CockroachDB database, custom object, which the developer or well anyone can create and then get a database created in a database running behind it, and in a database server instances running behind it, and this instance right now. Depending on how you see it, well, you need to put a bit more work in. And for example, if you would get like the AWS managed database service or insert any cloud with a bit more services than like, hey, server and nothing else. It may reduce your lock-in at least. Which, for example, I said with AWS with the Postgres, or well, we don't have support for the Postgres yet, but for example, CockroachDB or Minago could potentially reduce the login where you just go to Cloud 1, create a Minago object is the same as if you go to Cloud 2 and create a Minago object. So yeah, that's one of the points where you simply have to see the trade-offs. That's exactly where we're coming with the reminder there. It must fit your use case and your needs. There's no point in using Rook or well any other software if it doesn't fit your use case and or your needs. If you're, for example, willing to pay the AWS, you obviously have less to do in the end, because in Rook you, in the worst case, may need to jump in yourself and do something. But Rook tries its best there, again, to say, to automate as much as possible. Yeah. Now we're coming to the point of modern Ceph. I think hopefully everybody already got to know now in the presentation. Ceph is not the only thing Rook can run. There's, as said, for example, the Rook Minago operator, the Rook CockroachDB operator, the Rook HFS operator, the Rook NFS server operator. There are special thanks to the Nexenta HFS guys for them coming to us and hey, we want to integrate it with Rook, and they're working hard to get it to a more stable state right now. I think it's even pretty good, in pretty stable way stage right now. It's pretty good to see the community kind of coming there and saying, hey, we want it, and it's implemented by the community basically. Yeah. Now should be let me go back. I think the agenda is wrong. Oh, well, yeah. How to get enrolled? No. Well, it's open source. Go on to GitHub and well, hack on it if you want, if you have an issue or something, or if you already just see a typo in the documentation or so. But don't forget the, like this, what is it called, DCO sign-off that you need to add to your comments. But we'll let you know if you have forgotten that. Simply also on the rook.io page with the documentation or something. Look at it, doesn't make sense to you. If you see something that doesn't make sense, ask us. And, well, if it's just a typo or something, I said, go ahead. We're happy to see contributions of any kind. Then again, we have Slack. We have especially for conferences and for example meetups like this, we have a conferences channel. It's kind of, especially when for example KubeCon is, it's more or less like hey, we're currently here and here. For people that have interest to meeting us or just talking about issues or something, or even how good it works for them when we're talking about the negativity with issues there. Well, we have a Twitter also. If we tweet from time to time when we have a release or a cool brand new feature currently master, or just some general post about what is going on with Rook. We also have a mailing list, which is sometimes used, I think. I think Slack is more common. And we have, every second week, I think it was, a community meeting where you can bring in your points in a Google Docs document, which we then it will be presented to everyone in the during the meeting, and then we just talk about the points that are relevant. Right. So now to the sneak preview, which is kind of partly also a demo, but more or less just a cool thing. This is, I just thought it would be interesting to kind of see what, in my case at least, what I'm currently working on. As we kind of have a bit, 2 weeks. So, right now, our website is, more or less just focused on Ceph, but that's okay. One of the points I'm currently working on, I'm trying to get a page more general, hey, we are Rook, and those are all the storage backends that are supported node, and on the special note, we have a big problem with documentation right now. Not only because some things are simply not documented right now too good, but also because of the structure. We only have one level of depth in the documentation. So just to kind of show you, I wonder what root news site design.github.io means. Currently, this is one of the more specific parts that I'm working on, is simply that to have multiple levels of depth for the documentation, to have it a bit more visible. That we're still trying to work on getting this a bit more compacted. If you, for example, on Ceph, you don't want to see like CockroachDB documentation things and so on. So it's that's one of the points we're currently working on. And the other part, which is pretty often requested from users, especially running like on AWS or so. Being able to run a Ceph cluster from the cloud providers given like block devices. For example, with AWS, you have those EBS volumes, and you want to run Ceph directly on those. Right now, you need to do manual work there to mount EBS volume or multiple EBS volumes to each node, and then specify them in your cluster definition, which is it can be made better because, like in Kubernetes, you have those cool persistent volume claims. So why not just use those? And this is exactly what is behind this. That as long as there's a storage class, we will, in Kubernetes for this cloud provider, we will try to make use of it there in an arbitrary way, so that in the end any cloud provider can be used, or any cloud provider's block storage can be used, especially for example Ceph.
Do you have a Helm chart available?
Yes,
Yeah.
for the operator only. So we have a few people, we have a good amount of people also having requested them. But
I haven't seen it on the documentation.
the operator helm chart or the cluster helm chart? Let's talk later.
Yeah.
Question in the room. We can either kind of take questions now and then jump into the demo, or jump directly into the demo and Good. Then let's hope the demo gods are with me and everything's going soon. I'm connected to the cluster just to show. I have a brand new cluster just 58 minutes ago. Not like my, I think, what was my record, like 1 year or so. So,
Is there a specific reason for using such an old Kubernetes?
yeah, because the tool I used to set it up, well,
Okay.
I hoped it would use a more up-to-date version now, but I'm out of luck. At least the Kubernetes cluster is working, so.
Okay.
But for example, Kubernetes 1.13 it is still important. Damn it. Yeah. So let me get one of those let me get another console open. So maybe bigger. There we go. So right now we have the cluster is currently empty, and now we will go ahead, create the operator on it. We should a bit of time. And voila. We have the Rook Ceph operator part currently creating. Let's wait for it. And oh, just for that, you know, we just created the operator YAML. There we those top things. Those customer resource definitions we talked about, those are defined in this operator YAML. And here it's the full API path for Kubernetes. And we have created our own volumes, Ceph block pools, and so on. This is just the Ceph operator. We're here, it could be a cluster example in the Ceph. Yeah, and some other stuff like cluster role, service comments, like the standard RBAC stuff that needs to be created for an operator to run. And yeah. So let's wait a few more seconds that everything above there is running, and it seems that we have a good chance of in a few seconds that everything is running. Perfect. So, what we are now going to do is jump in the cluster.yaml to have also a more up-to-date example with current Ceph cluster. We're version 1 for Ceph there at least. We have parameters such as which Ceph versions should be used, which data do you post path, how many monitors from Ceph side you want to run, and if the dashboard should be enabled, networking if it should be host networking, and so on. A few more special stuff like placement again here for the components, resource limitations. Here. Again, here we have, in this case, only nodes that they don't have a second disk, so we just have to use all nodes true. We don't really need the device value because we don't have any devices to use in this case. So we will just rely on Rook Ceph there to create an OSD in a directory in the data DNS path by default. Even though it's, as I said, you can specify placement for each component. It's, for example, this config here for the Ceph OSD, some special stuff there. It can not only be specified on a cluster-wide scope, but you can also specify it per node. So if we go deeper here, for example, a nodes list basically, which will then be used. We're, for example, known with this name, and we'll have OSD, Zeta store created in rook/storage -dir. Have those resource limits then. Further down, for example, here this node with those devices, and this device, for example, would have a special configuration of, in this case, with the, to keep it simple, the option OSDs per device is 5. So that is also possible. For example, a custom device filter for this node. But just to note again, currently it's either the nodes list or use all nodes. So it's not like you have use all nodes and then specify a custom configuration per node. This is one of the things I kind of came across like 2 days ago, I think, or last week at a workshop about Rook, where it was exactly like, yeah, but you have those nodes lists, yeah, but you need to maintain it manually. But what if I just want to override like an option for one of those on the all nodes? Like, you're not wrong. So there will probably be changing that in a behavior soon when I get to it. Let's exit out of the farm for a second. So in a Ceph system name, a Rook Ceph system namespace, we have those special daemons like Rook Discover, Rook Ceph Agent, as I said, discovers devices. The Ceph Agent is doing the mounting, in this case, still the Flex Volume Mount plugin, which is for there for the kubelet to take requests from the kubelet that some module X should be mounted on this node for this application and so on. And well, the Rook Ceph Agent does that. And going to the Rook Ceph namespace in which we created the Rook-Ceph cluster object, we have now spawned the, for example, the manager component, which all Rook operator did in the background, the manager component, the 3 monitors being spawned, and the OSDs being spawned by, prepared, to put it like that, by separate jobs for each node. So each node which is then selected for storage will basically get a Rook Ceph OSD prepare job, which will, prepare this node, for example, if directory space are used, which in this case is true, they will prepare this directory to be used with, as a Ceph OSD, and in general just create some configuration for this component, for the OSD components which we run over here. And because of that, we now have 3 Rook Ceph OSDs, which, they count up in Ceph from the OSD number. We have 3 of them running. Let's create the toolbox that we can take a closer look. And to service for the dashboard that we can take a look in a few seconds. We have the toolbox now. There we go. And if we run, for example, the quick summary Ceph health command, we see that we have 225 gigabytes in total there. 203 is still available, as it's using the directory in the root partition of the VMs. There's obviously a bit of space missing, but just in general, there is a node with the storage. If you move it up, there's a bit more than just, for example, in this case, the OS is taking over the space. This is simple to the fact that Ceph is, it's not like, how should I put it like that? It's not just one binary or something and it creates one file and writes data to it or something. It's more, it has to do some housekeeping, some statistics and stuff like it, just keeping some numbers of where, for example, what data is stored and so on each for each OSD already. So there will be always a bit of overhead there. You don't wonder if you have a bit less than even with dedicated partitions where you have a directory now, especially with full devices we have less, because especially with devices, there are two other partitions, or one at least created, which is taking off a bit of the storage there to store like metadata or journal data for the data which should be written to the list. If we now quickly go ahead and just check our OSD tree, we see our My Cluster Worker 01. Where do we have it? Here we have My Cluster Worker 1, so we're here with OSD 1. Same goes for 0, we see 0 is on this node, but no, we see the answer from the pod placement there. Yeah. Now if we go ahead, exit out of the container, let's say we want, for example, to create, to run a MySQL on it, we need to go, that's right. We create a Ceph block pool, so that pools are created in, that the pool is created in Ceph to be used as block storage, and we create a storage class which is referencing this pool we created named replica pool. And if we go one back and if I run that, so we see we have our storage class there created. And if I go ahead now and create MySQL, and for that is a bit quicker in the end for another part of the demo. If I now run kubectl get pvc, which is which is simply short for persistent volume claim or claims with SVM. We see we have two now, one for the MySQL container, which in this MySQL.yaml there's a simple defined persistent volume claim and some other stuff, deployment and so on, and well, MySQL is spawned from it. And for example, the WordPress persistent volume claim, which, well, same again, you have persistent volume claim in your deployment YAML, which I can here, here we go. We have simple doesn't want claim again. We say this storage class which we created in this access mode, we want the storage and 20 kilobytes. And with this information, the Rook operator creates this volume in Ceph and the persistent volume. If we take a look at this, so we see two persistent volumes. PV is short for persistent volume. We see the capacity, which access mode, reclaim policy, the status of it. In this case, bound is meaning that it is bound to a persistent volume claim. And the claim name in this case, in the name for this default, named in this case WordPress PV claim or MySQL PV claim, and from which a storage class. The reason, then it's, I think, what was it? When it's deleted or something, the reason is shown, and age obviously, which how old these persistent volumes are. So, if we go ahead, and take a look at the WordPress, for example. The WordPress. And quickly grab ourselves the IP of one of the we should be able to, yes, yeah. So we have a WordPress now, which, well, it's a WordPress, what is there to say? Let's just copy the lines. I need to see the password. Well, just to have some data then in the end to demonstrate that the data is replicated, and well, if we delete the WordPress part, then that's already done. We could also update that. Updates are overrated. And if we go ahead and publish the post and go here, we see our post is here. If I switch back to the console, and let me display me the pods running. Let's say we delete the MySQL pod, which is on worker 2. Remember that. We need it in a second. We delete the pod. I don't want to wait till it's deleted. We see that it's currently terminating, and in the case, because it's a read-write once storage, read-write once persistent volume, it will wait till the other one is terminated and the volume is basically without again unmounted from the other node. So if we see nobody on top, so in a few seconds it's running again. If we follow it, well, it's already started, so if we go ahead and refresh, data is still here, and the more important thing which I just totally forgot is even on another node. So, well, we have basically a storage which is, well, not only available on node 1, but also on node 3, so, yeah, that is a, pretty simple example just about the block storage there.
Where was this MySQL before? Was it also by my cluster? Number 3?
I hope somebody in the room remembered when I said remember.
I'm not sure.
2? It was on 2.
Okay. So you could basically also have deleted the full node and everything would spin up again.
Yeah.
Okay.
So in most cases with Kubernetes node failure, it's more or less also depending a bit on the pod. Do we have this 5 minute and 40 seconds timer until the eviction of pods is happening? So it should, but it's taking at least this time. And the problem is, in my case, it's working for like. I think I never had that problem, but some other people had some trouble with it. But yeah, you know, you probably already had some issue with like it's working for me, but not for the 10 other people. So you know, like there's 50-50 that it's not working, it's working.
Yeah.
But it's if you should encounter this, if you should try out Rook, let us know. We'll be happy to look into it further. So just quick, I've deleted it again, and we're still on the free. Oh no, I deleted the WordPress one. All those WordPress ones. Now finally, was that the one already? Oh, yeah. It was previously on two. Now it's on one. And it's looking at the top, they're running. So the goal is met in this case. We have block storage which is available on all nodes in the cluster. With all nodes, it's meant all nodes which have the Rook Ceph agent on it. The Rook Ceph agent is, well, as it is doing the mounting, well, required on all nodes to then run applications in home storage. Yeah. And well, as a
what will happen if all nodes run out of storage? So is this some kind of service classes for certain files to write, or just something?
it will warn you before you reach it through the metrics,
But if you don't notice, what will happen?
storage will come to an halt.
Okay.
If you're at like, what was it, I think 95% per OSD in Ceph terms, it's, it will come to an halt. It's kind of like a data protection. It's simply not accepting any more reads, especially your writes in this case. So if we now go to the cool, was this one? Yes. It was HTTPS. HTTP is not. As we have it secure, we need to get a password from the system. So everything is done, there's no secret. So please look away here. I don't think you can read that. Forget about it. Forget about it.
We can't remember.
This is the dashboard in yeah, this is the dashboard of Ceph Mimic. It's one of the release names. Well, you have a bit of log here and how many objects are currently in your cluster, say the capacity and the raw capacity, the usage by pool. In this case, we have only one pool, so basically all storage is taken by this one pool. Here we see again a bit that the actual usage is 0% right now. There are no operations happening. We have one managing elements on. So it's just like a bit of it's not like Grafana. You can also plug in your Grafana endpoint of like going against the endpoint for Prometheus metrics and using Prometheus. For metrics like in form of Grafana, or if you kind of want something where you can look and even create something. So if I want to see some info on the monitors or something, I have it here on the dashboard in a bit of nicer form. But for example, also with block, I can create an image here if I want, or like see my pools, how they're doing. Well, I don't have a file system. For example, for the object gateway, see what's going on. I don't have one, so it's not really showing and not doing anything. For example, for the OSDs, we have information like how many bytes are read, what's the usage on it is, of the OSD, or in this case the directories which we have on the servers. Yeah.
Another question. For example, if you have a really hard demand on read performance, can you read simply about over certain devices with read?
With Ceph, you can, I think you would was it the chunk size, if I remember correctly, or the striping size it is named. I think we don't have support for this to be automatically set in pool creation, but yeah, I think it would be in safety striping size, if I remember correctly, which you can use to well, stripe the objects to multiple OSDs. But that kind of goes in the same direction of we simply specify, depending on how big our survey files are, to have a smaller chunk size of the data you're storing. By default, it's 4 megabytes, which I think somebody once said that because of exactly those 4 megabytes of default chunk size in Ceph for normal data in general, not data, it's normally losing against raster when you write small files, because if you write a small file, it's basically writing 4 megabytes to the disk, and it's kind of like you have to know what you have. If you have, as a big files, 4 megabyte, or even possibly bigger of a chunk size, maybe makes more sense, but it depends on the So, kind of as a point here, if you want to run Rook Ceph in production, you should look a bit into Ceph a bit, because it's, you know, it's still Ceph. We try to manage most things and automate most stuff, but if your whole network blows up or something, it should hopefully mostly recover. At least in my test cases I ran from time to time, where like kill all servers at the same time with a hard reset or something. I didn't experience too much issue besides all the components coming up again, taking a bit of time to reorganize themselves, and the cluster to basically rebalance out again a bit the data that was lost on the OSDs that were not yet up again and connected to the cluster. But on the other hand, you can also do some stuff wrong. If you, for example, work with the Ceph command client all the time or RVD, so you can probably screw something up. But that's again where you have the operator which creates the volumes for you and so on. So in the worst case, as with all software, it can basically go down the drain. Yeah, parts of those files, I think they're still outdated, or at least I didn't add the files for this meetup yet. Can be found in a GitHub repository. Yeah. But more or less the Rook documentation has a good Ceph Rook, so just use that and use a release branch and not master. Try it out. I would be happy with that, because master has potential problems or incompatibilities with it's, you know, you look into, especially with compatibility when you're going to release, not like really like where you just at least don't break everything, but so use a release branch in the repository, and especially we have this, not too deep documentation with levels from the navigation, but if you are on a, for example, older release, we have a big blue box, or my favorite, for master. Please no. Yeah. That's Ceph. That's Rook and Ceph. Rook Ceph operator.
Can you connect it to an already existing Ceph cluster? Would that make sense at all?
It would more or less make sense to move components like monitors, managers, MDSs inside of Kubernetes, because if one node fails there, those components can just spin up on another node. But for OSDs, it's still the same principle that the disks are there, so if it fails, where else would you want to put it? You normally just have enough OSDs for the data to be then, the data that was on the node to be rebalanced on the other OSDs, that the data is back to the replication count that it should be. Questions?
So, what are your experiences with like production usage of that? So what I heard so far from colleagues on Rook Ceph is that it's fine if you restart it every 3 days or so.
Which Rook version?
So what are your experiences with that?
Well, at least maybe not to the hey look quick production or so, but in my what was it 8-node bare metal environment with like 2 times 4 terabyte disk per node, they only had gigabits. Well, the thing that broke all the time was Kubernetes, and not Ceph normally, because like what was it? Docker was broken at some time in the cluster. Then it was Cryo. Try out Cryo. It's cool. It's working for most cases. At least in my case, it worked better in the end than Docker. I should say. Or in the end, for example, as I'm more or less in a public environment, I'm using the Google DNS servers, and they were broken for a few hours. Which, well, if your cluster goes all not ready, then you will. As with a normal Ceph cluster, if all nodes would just go like, yeah, what am I doing here? Nobody's here, or I have no connection to anyone because I can't resolve the names. Yeah, it would be interesting to hear which Ceph version, or well, which Rook version it was. Because especially, well, with like, what was it, 0.9, which was released like last year in December, just before KubeCon. It was on the meeting. You can now specify which Ceph version you have. So normally you would have waited would need to wait for Rook to update and use the new Ceph version, but right now it's like you want to use the latest Mimic or the upcoming Nautilus Ceph version, go for it. And with that also it's more or less possible for us to say there's a bug in component X, like a manager or something, to say, hey, can you try this Ceph version? And not go like, yeah, you go and compile the whole thing and change this variable to this Ceph version, and then it will, it's easier now with the serial. As for some issues, for example, the manager is kind of a problematic children in my perspective right now, as we just had some manager problems. One of the problems was just a permission issue from our side of the keyring, the access basically we gave the manager to the Kubernetes cluster, to the Ceph cluster, but some other issues were like, where, you know, Ceph is like, I think 10, 20 years old or so. As it's like the newest component right now, it's feeling like it's new. So it's getting fixed. We have great support from the Ceph community and from Red Hat also, which I also see Rook as a good thing to support and also possibly, well, sell to people at one point probably, or at least support. Yeah, so if they have problems, ready on the Slack and ask for help. Have they? Or have they at least created a ticket?
I'm not sure on that. And it wasn't with the news release, so and I heard it's getting better and then more stable. So
Till version 0.9 we ran stable, it was beta. So
so is it no longer in beta?
Huh?
Is it no longer in beta with
Only Rook Ceph.
0.9?
Rook Ceph part is in stable.
Okay.
So everybody we have is like we have to but the other scenarios are still in the alpha stage, which if we use this key, we need to put up. Oh, here. Yeah, the current status for Ceph. Root framework itself is still alpha. You know, we just have two providers using devices. For example, it's still open. If this is enough, as we have it like right now for device selection and so on, as we have, for example, for Ceph working on LDM support, we have to ask ourselves if we want to have some separate selection for LDM and so on. So But well, yeah, so Ceph is stable basically from our side. And
But wouldn't that mean that the root framework is still in alpha mode, that I could expect a lot of changes if I run that in like production?
the framework itself has changes, yeah. But the code itself is more and more stable. I think we're basically at the point where it's like it's stable, but we can get it more stable by fixing stuff which potentially can occur, simply improving also process like the creation of the OSD where the data is stored. The manager part where we have those issues with permissions and stuff like that, which we are fixing and improving on to not happen, especially for newer than Ceph version, which is yeah. The other side, for example, HFS is also brand new, so yeah. But both here, by the way, Cassandra and HFS, I think also NFS community contributions. So yeah, we're happy to see that.
I have a question. I'm not very familiar with Ceph, sorry. At home, on-prem, I have a Kubernetes cluster built with Raspberry Pis. I was able to manage to attach an NFS.
The freer version or the old one?
3, yeah.
3.
It's completely full. It's just for me to practice a bit. Is it correct to say that it would be possible in the long run, probably, to attach for every Raspberry Pi this USB disk, for instance, and then store data on it, so that you can disconnect, for instance, the slaves step by step, so that you remain with the master only, probably, and everything is still running. This is a very high potential, I know, but would it be possible to, with Rook, something like this? A setup like this?
Yeah, well, Rook has from Ceph side of Ceph supports ARM64 as the official.
Okay, yeah, that's another
you would
problem.
just need to have Debian with 64-bit on,
Yeah.
or in general, yeah,
Well, that's the vision.
it should work, but it's problems like USB bandwidth because Raspberry is still USB 2 and so on, like
Sure.
those problems.
Yeah. And would it be possible also to, for instance, disconnect the USB stick of the master and then still continue with something in the cloud provided by Google or by Amazon?
You mean that you have your Raspberry nodes connected with a cloud Kubernetes?
Yeah, the master, for instance, have a.
The Kubernetes masters? Or what do you mean with masters then?
Uh,
Well, in Ceph's concept there are masters, but not like in that concept.
no, I mean,
With the Kubernetes where it's free.
I also managed to, for instance, make a backup in the Amazon cloud by using Arc. This is a tool.
Yeah.
So you can store something also in the Amazon cloud storage. So it would be nice to have some kind of backup. So even if the master disk fails, so that you can still get your data from the cloud.
But as said, there is no master. The data is replicated to basically then any Raspberry Pi that runs the OSD. Well, as long as you don't change anything in the Ceph environment. But you have 3 Raspberry Pis and you have a replication of 2. Ceph will take care that the data is 2 times available in the cluster at all times. If you remove one as Raspberry, all data that was on that Raspberry will be replicated again from the other 2, or when the other one that has data to the other, to the second Raspberry, for example.
Yeah.
There's a there is a concept of primary data, or the primary placement group where the data you just put on the block storage, for example, is safe. But that there is no actual concept like with masters. The masters normally would be the ones, but those are normally covered with exactly you run free and one fails, you have to form still.
I mean, with master, I mean my master in the Kubernetes cluster. But you need, what you're basically saying, you need an OSD, whatever this is, in the cloud as well. So that the cloud storage is equivalent to the.
Sorry, I
Yeah.
think we're getting into a really detailed question. I'm not sure
Okay.
if everyone is
Yeah.
following you along, and I'd say discuss that with
Yeah, we
in your
can
hands later
discuss
on,
it.
and
Yeah.
I'm hungry, and I can I guess everyone else might be hungry too. So thank you very much for the deep insights, and
Yeah,
yeah.
just advertising. What button was it? The 5? Ha! Just Twitter and all that stuff. Yeah. And yeah, from time to time on Twitter, but not on Twitter. More stuff about Rook is on the from vulnerability report, talk report. Yeah.
Okay, thank you very much.